Yeah, mic session. Cool. So I already went over the agenda. So without further ado, I'm going to give my presentation, which is really just Zig on the web and my personal evolution of using Zig on the web. I know Zig is not only on the web, and there's probably a lot of people doing more systems programming stuff with it, which is also fun. But I particularly was trying to use it for some web stuff. So look, Ma, no JavaScript. I have an app now that has very little JavaScript, and we're just going to go through my evolution with using Zig on the web. Okay. So last year, I spent like a year after a game jam that I did like 5 years ago or something, just realizing an idea I had way back then, which was uh, like I worked with a guy who was like, I forced him to write JSON basically, and he's not a coder. So I decided like if I could just make like a flow chart that he could just like use to like draw like who says what and then what choices you have to respond or whatever, like for a dialogue, I was like, that'd be cool. And then if I do it in Zig, I can like make a C library and then I could load it in the website so that like there at the bottom, I can like play back what they're writing. Like, so the designer just like writes some stuff, creates a flow. Like this guy says that, there's like a 10% chance he says this instead of that. And then they have 5 options of what to say after. So anyway, basically there's a C library that's compiled to WASM run in that web app. The front end is React. It's all normal HTML5 stuff. But then you can take that same C library that Zig outputted a C ABI for, or sorry, it's in Zig, but C ABI, and you can like embed it in like Mac, Windows, different game engines or whatever. So I did that last year, and it was kind of fun. But this year, I wanted to sort of step away from this flow graph stuff and really work on an actual scripting language, but it's a visual scripting language. So I want to do something like what I had before, where it was in the web. But I also kind of wanted to eventually be a native app. So those are my requirements, and I think Zig meets those pretty nicely. And another thing is I want to do some compiler work with this thing. I want to eventually compile some of these visual scripts. But I'm probably just going to start with the front end because there are a lot of good backends out there, except I'm not going to put LLVM in the web. That sounds, I don't know if anybody's done that, but that sounds kind of ridiculous. But Binarian is the one I'm using now, which is a WebAssembly backend. So why visual scripting? I don't like writing visual scripts these days, but I used to. That I over there is actually written entirely in like shader nodes in Blender. I did that like a long time ago. It was horrifying. There were like 200 nodes. Yeah, I don't want to do that again. But I do know some people that do like this stuff. Specifically, I used to work with a bunch. I worked at a company that made software for architects, and they love this stuff. So I just want to make their lives easier. I know a bunch of like artists that like work on games and stuff, and they love using Unreal Engine. It has this ghastly looking thing over there, which is like coding with visual scripting, but for logic rather than like shaders. So although shaders have some logic, but yeah. So I had some ideas about this stuff, and I want to see if we can not make it that spaghetti over there. So again, I'm just making a generic visual scripting editor for testing some of these ideas that I have. It's totally a prototype. I'm going to show it to you right now. Very ugly. I have a tree formatting algorithm that auto lays out the nodes for you. Very ugly. And I rewrote the UI this week, so that's part of why it's ugly. It used to look better, but we'll get into that. I'm not going to take too long. But anyway, okay. So this is what it looks like. Basically, just you got some nodes, and I'm using a library called DVUI, which maybe you've heard of. I think technically it's David Vanderson UI.
Yeah.
Nice guy. He helped me a little bit. He actually has a better looking, he created a sample for me about how to not write it like to look this terrible. I just haven't adapted it to my code yet. But nice guy, great library, and we'll talk about it more later. But yeah, so I have, context menus. So yeah, I can right click and then these like all the nodes I can place. Some of them have horrible names. But like I can place like a division node, and then I can also like drag out a value and then contextually see what types or whatever are available for that value. It's not really complete at all, so just some semblance of filtering. But here I can like attach a plus node, and then I can drag out division node from there, and then go like 2 divided by like 16 or whatever plus and blah blah blah. So yeah, that's it. That's what I'm working with. Going to try to add more features to this, specifically today too. So yeah, so I went through 3 phases of using Zig in the web, from the previous project to this one pretty much. In that previous project, Alternus that I was talking about, which by the way, I forgot to mention, is actually on the internet as alternus.io. I don't really advertise it because actually the WebAssembly part I'm talking about is broken. But if you want, go check it out. It's probably a tiny bug. It used to work. I just need to go look at it. But yeah, so what I did was I just did handwritten marshalling code. So with WebAssembly, if you're using Zig and WebAssembly, you basically have to be like, hey, Zig, give me some space in your memory, and then give me a pointer to it and tell me the length of it. And then I will write a bunch of stuff from JavaScript land to it and then tell you to go act on it. And that's your serializing basically stuff to that buffer. So you're like, it's called marshalling, moving the object representation from JavaScript land to Zig land. So I did that. It was really annoying. Not that bad, but it doesn't scale a ton. And you can't use a bunch of Zig like niceties like the enums, the unions and the slices. So I started with this too for the project I just showed you guys because I forked alternus to make it to the start anyway. The second phase where I would actually stop is this awesome library that I don't know if any of you guys have heard of called Zigar. I don't know how many of you guys are actually trying to do Zig stuff in the web, but Zigar is really just like they generate all those things for you, and you can use slices. You can basically use any Zig type except for function pointers. It's an awesome library. The only problem is that they apparently misused. I was like, my app started crashing after I like ported some of it, and apparently they misused the raw allocator interface right now. I need to do a bug report. Haven't done it yet, but they like misuse in such a way that an object gets put in the wrong free list. So it causes an alignment crash later. So unfortunate, but I was like, you know what? I said when I was setting out to make this thing that I want it to not just be a web thing. I want it to eventually be a native thing. So I was like, I'm just going to go full for it, and I'm going to go to phase 3, which is DVUI, like I mentioned. So now that entire app you guys saw uses basically no JavaScript in the logic at all. There's a tiny dependency, like a little wrapper for hi, Antonio. I met that guy outside a bit ago. He's a physicist. You guys will all meet him, maybe. But anyway, sorry. But anyway, so they have the JavaScript layer that just like uses a little bit of bindings, some glue to the WASM to be like, here's how to render geometry to the WebGL context, and then Zig does the rest of the work. And it runs for every browser event. It runs my Zig code for rendering. So now I have that thing, which is, not just running the web at a pretty good frame rate, but at a great frame rate, but also I can move it to a native platform really easily. And that's one thing that's great about Zig. So yeah, besides that, I'm looking forward to looking at the compiler side. I just wrote some bindings for the Zig build system to build Binarian, the optimizing WebAssembly compiler backend. So I'm now writing a compiler front end for my visual scripts. Even though they don't look great yet, but I'll worry about that later. I want to get the compiler functionality going. So yeah, that's what I'm working on today. Thank you guys for listening to me. And hope we have a good time here today. So we're gonna move on to the next presentation. Thanks, guys.
Yes.
Yeah. I was gonna ask. I forgot to say like raise your hand if you want a question. But yeah, questions.
What is the input to a visual compiler? Like you're not lexing and parsing.
So yeah, so basically you just skip the lexing and parsing phase. Now, I'll be honest, mine technically has like some extension that has some like parsing, but really you just have, instead of having an AST, you just have the node graph. So you can just like create the control flow graph from that, pretty much. And certainly that's what I'm doing where I already have an existing backend that I'm using. So I'm just like running through the already existing tree and just skipping the parsing and lexing phases. So it's easy. It makes that part easier. Yeah, but it comes with its own challenges.
But you're thinking you want to target like a full Turing complete language that can do arbitrary math and graphics and whatever.
Yeah.
Or domain specific.
So I think that's one of the main things that I'm experimenting with here is I want a full Turing complete visual script. I think one of the things that no one I've seen before do with visual scripting is like sort of let it outside of some sort of host where it exists. Like you can't really like create a visual script like Unreal Engine that I was talking about in Blender shader nodes. You can only use Blender shader nodes. You can't export them to like a GLSL shading language. With Unreal Engine, you can't run without like the Blueprint VM, which only exists inside of the Unreal Engine runtime. So I'm basically going to make it compile WebAssembly. So that's the plan. Yeah. Any other questions?